Welcome to our YouTube channel. In this video, we are going to do design of substation gantry structure in Eurocode with robot structural analysis. This is a stage 1 out of 3 which we are going to discuss about the primary loads. There are 20 number of primary loads listed here, and in that we are going to apply this primary load in the structural model which we had prepared earlier. The structural model video preparation, you can see the link for the video in our descriptions, and similarly like for this primary load calculation also there is one video we had released in YouTube. You can find the link in the description. So before watching this series of videos for design of substation gantry structure in Eurocode with the robot structural analysis, we request you to visit those two videos. One is the modeling of substation gantry structure in robot structural analysis and the primary load calculation. So let me go to the demonstration. You can see on the screen there is a 2-bay gantry structure which we had prepared earlier, the model in robot structural analysis. In this, what we are going to do is we are going to delete one bay in order to simplify our calculation or our demonstration method, because applying on the 2-bay will lead more time. What we are going to do is we can able to apply the loads on single bay, and later wise we can copy paste like we did in modeling video, so that we can able to apply for the 2-bay load itself with a simple manner, instead of applying in the 2-bay and directly the loads. We can do it in a single bay first. So for that I am selecting the other bay in the right hand side and deleting. So click OK. So now we can see there only one bay. We can find out the number of members in the object inspector. So now we are going to apply the load which we had calculated earlier. For that, first we are going to apply the conductor and earth wire loads and its hardware or suspension insulator. For that, we are selecting the top of tower and the girder face-to-face distance or conductor connection points. So after selecting those, click this edit in a new window. So only the selected member are visible here. So in this, even we don't want this cross bracing also, because we are not going to apply on the cross bracing. So we are going to apply only the bottom member of the conductor fixing area. So we can deselect this cross bracing and top bracing and even the vertical members for conductor load application. So now again we can click this edit new window, so that only the point where we are going to apply the loads are selected. So now we can click on this node view also. We can find, because all the loads, the primary loads are of conductor and hardware and the earth wire, we are going to apply on the nodal force only. So you can see there are some other nodes are selected, so we need to deselect those. So these are the node where we are going to apply the loads. So can hide this node number. In the left hand side you can see the calculation sheet which we had done earlier. So these are the tabs: input data, wind and ice loads and load combinations. So likewise we had calculated in our earlier video. So these are the primary loads which we are going to apply in our model. In the left hand side you can see the robot structural analysis model, which we had consider only the members which are subject to the earth wire and conductor loads. So now we are going to apply the loads. Before going to apply the loads as per this calculation, we need to define the load cases. So let me see that. So we are going to define the load first based upon this list which we are having. So go to loads, click load type. In that add det load 1. We can label it as D, which is showing in the table right hand side. So this we can call it as det load without ice, add. So similar like det load with ice, we can call it as DI as mentioned in the table. Copy and paste this load name. So likewise we need to do for all the load cases. So for wire tension we can consider this as a live load nature, and for extreme wind, high wind, moderate wind we can consider wind nature, and for short circuit force we can consider as accidental load nature. So temperature, we already having the temperature nature, we can select the same as a default. For wire tension which we are considered as a live load, we can consider any category A, B, C up to H. There is no issues in that, because that load combination we are going to apply manually as like the factor which we had defined in the table here in the Excel sheet. So it is not a problem if only for the automated load combination system as per robot structure analysis only we need to define this carefully based upon the European standard which are mentioned. So for in this case, as we are going to apply a manual load combinations, this we no need to worry about this sub nature of the live load. So now we can apply the wind loads also. So now we had added the wind load case also for primary loads. So we are just copy and paste this load description and its load icon here in the respective cells. So now we are going to add SEF in accidental cases. So you can just copy this load description and paste here in the name, and the load icon copy paste here in the label, add. So similar like we can do the copy paste for the next load case also. So that could be short circuit force in 30-degree deviation. So the detailed calculation about this all this load 0 to 19 cases we had well explained in our previous video. You can watch the video by clicking the link given in the description. Next one is a final load is 20, which is a minimum temperature. That we can select the temperature in the load nature and paste this load icon here in the label and click add. So all the 20 load cases, the primary load cases we had added here. Then click close. For providing the values as which we had calculated earlier, so here are the summary for various load cases which we had calculated earlier. You can watch our videos to know how to calculate these loads. So now we are going to apply this summary values into our gantry structure model. So first we are going to apply the det load with ice, without ice. So you can click this loads and click load table. So we can also make this window horizontally. There are a lot of window. So we can close this, which is not required, and minimize this unwanted windows. So this is a window we need. So this also we don't want. So only these two window we need. one window is which we had selected for loading point. Another window is a tabular format to apply the load which we had calculated. So first one we are applying the self-weight. In that self-weight we need to mention the list of member to be added. So later we can apply this, we can see this. So next one is dead load, which is a nodal forces where we need to apply on the nodes of gantry structure model. So first the conductor load should be applied in 134 n span, n phases, and 130. So likewise, so we need to get this node value. So node list start from 138 space and 134 are the end loads. So in that f of x is 0, only the f of y is there. So it is 11.85, which should be defined in negative because it is a downward force. So we can also click the load view so that we can able to understand whether the load is applied properly, what we are giving here in the table. So you can see here, so those are applied, but this should be instead of 132 it should be 144, so that you can see here. And the next load is we are going to apply for dead load without ice in node number 150, which is a mid span 130. So the value for that is 12.85. Next one is we need to apply the vertical force on tower. For that we can select any node. We can select this node number 13 and 79. And 79. So this is also minus and the value is 0.3. So likewise we need to apply for next load cases also. Dead load with ice. So here also we need to apply the self-weight. Whereas here, as it is going to consider along with the ice, we can consider this factor as 1.2. Then again we need to apply the structural members list. So what we can do is we can do this in a later stage. So adding the nodal forces with respect to this calculation, which we got to have it in the right hand side. This is for dead load with ice. For this, both the n phases and middle phases are having the same value. So we can have this node number which we had entered here. We can copy paste here. This should be nodal forces. So likewise we need to add for nodes of 134, 130 and 138. The magnitude is 13.01 negative. So you can see like here. So similar like we need to apply the same for tower top also. We can just copy paste and only change this value, load cases. So here instead of minus 0.3, 0.96. So likewise we need to apply all the load cases as which we had calculated. So you can see our STAAD model. In this y direction is a force or a direction which is parallel to the conductor span. Here this calculated horizontal forces in Fx means it is parallel to the conductor span, so that we need to consider for a robot structural model which we had developed is y direction is parallel to the conductor span. So Fy equal to Fy in robot structural model is equal to horizontal forces Fx which we had calculated, and Fx in robot structural model is means equal to horizontal forces in y direction, that is Fy which we had calculated. So likewise we need to apply the load cases. So we can minimize this window and we can maximize the record window. Yes, this is a window we need to apply it here. So for applying the wire tensions, all these three phases nodes are required. So my 20 kilonewton is the calculated value here in f of y direction, so we are entering the same. Similarly, like for tower, the same node 13 and 79 we can copy paste, or we can directly enter here and apply the value is 5 kN in y direction. So similar like we need to do for wire tension, that is a fourth case which we had calculated here. The same summary value we have to enter here. So here this node alone we need to copy paste here. So then the similar like we entered earlier. So likewise we need to apply for all the load cases which we are having here in the calculated Excel, or simple we can copy paste this in next tab and we can change this load cases alone as a 5 and enter this value as showed here in the table, that is 50 here in the conductor and 20 here in the earth wire. So here from the load cases 6, 7 and 8, there could be 3 directional forces, as we had calculated the conductor with the deviation of 30 degree both horizontal and vertical upward. So we need to enter those values here. So in f of x we are having 8.67 and f of y it is 15 and f of z it is 10. So for tower peak we need to apply the same like 2.17, 3.75 in f of y and 2.5 in upward vertical direction. So you can see the arrow mark definition here. So the same approach we need to do for other cases such as 7 and 8. Like we just copy paste this last 2 load and change the load cases to 7. 7.5 for vertical upward it is 5. So we can copy and paste for load case 8 and change the values. Next we are going to apply wind load cases, extreme wind load cases. So in that again the nodes are same like a conductor and earth wire. So only this f of x value and f of y, f of z value can be changed. So here in that load case, this is a load case 9, this is load case 10, this is load case 11. So for 9, we are having f of y as 3.21 alone. So there is no f of x. So we can directly enter the f of y value here. Sorry, here for conductor and hardware. And for earth wire fixing, there is no loads. So you can consider 0 for all the cases. So you can delete this row instead of that. So next one is load case, extreme load case for 45 degree, extreme wind for 45 degree. That is, for that we are having the same conductor node. But in this we are having both f of x and f of y. You can see in the load case wind 45, that is a 10th case here. So again we are going to apply for earth wire. So in earth wire case only f of x is available. So next one is we need to apply the wind, extreme wind cases in a 90 degree. So there is also 2 rows we need to add it. One is for conductor fixing area. In that we are having only f of x as a 7 kilonewton. Similar like for earth wire 13 and 17 we are having 0.82 because we need to refer this wind 90 direction. So the same way we are going to apply for load case number 12, 13 and 14. So just copy and paste here. So instead of 9 it should be 13 high wind, and instead of 10 it should be 14, instead of 11. So we had to change the load calculation, load cases after copy paste those 9, 10 and 11 here, and the node number remains same. Only thing that load values is going to change. So in the right hand side table you can see for high wind load, so 2.41. So this value we are going to enter here based upon the wind directions. So here it is 2.41. So likewise we need to enter all the values. So after entering all the value, again we are going to copy paste from load case 12 to 14, and we are going to change this load case 12 as 15, that is moderate wind in 0 direction, and 13 to be 16, that is moderate wind direction in 45 degree, and 14 to be 17, that is moderate wind in direction 90 degree. So again here we are going to change only the load values from load case 15, which is showing in the right hand side tables. So now we had applied the values of moderate wind also. So while selecting this itself, you can see the window, model window. The values and the directions are changing according to the load cases and the load values and its load directions. So next one is we are going to apply this accidental load short circuit forces. In many of the European nations, they don't have these short circuit forces because most of the gantry structures are used as a line entry gantries. So there won't be any short circuit forces because the transmission line entry are having more face-to-face distance, where the connection point at substation gantry structures may not have much short circuit forces. So that in the European nations, most of the short circuit forces calculations are ignored while going to design for gantry structures. However, we are having this as in some exceptional case, there may be short circuit force to be considered. So that load case 18 is a short circuit force. So similar like we are going to apply this both conductor and earth wire loads. So you can copy paste the nodes of conductor and earth wire here and paste here. So then we need to enter the value. In f of y it is 70 for conductor and 5 for earth wire, because in earth wire case we are considering only the normal tension instead of short circuit force, because the earth wire is not subject to short circuit forces as there is no uh, electromechanical fault or anything is going to appear in earth wire. So next one is a short circuit force with a conductor deviation of 30°, that is a load case 19. So we just copy paste this 18 into the new row and we are changing these load cases, and the node are same as in case 18, only the values is going to change here as per the table in the right hand side. So 52 in y direction. So likewise we need to enter those value here. So finally we had applied the load cases up to 19. Then the remaining is load case number 20, that is a minimum temperature. So this minimum temperature we need to apply for overall structure. So now we are going to apply loads on structures. So first one is a self-weight. So for that self-weight we need to select the load member groups first. So click this, go to group, select all the member group, click this upward mark so that all the groups except the dummy member are selected. So you can click and renumbering, start from 1, click apply. And for dummy member also you can give the renumbering, start from 2001. Now we can know that member which are start from 0 to or some 0 to, so 1 to 570 members are considered to be a structural member, and the remaining 2001 to 2008 are considered to be a dummy member. So here in the load table we can directly apply the list of members, that is 1 to 570 are to be considered for structure member weight. We are not going to consider the self weight of the dummy member. So for applying this self weight tab, we need to select as partial sulfate. Sorry, here in the instead of the old structure we need to select the part structure and enter here 1 to 570 so that the numbers are applied here. Similar like for here also the part structure we need to select only the 1 to 570, and the next one is we are going to assign for temperature. In this temperature we need to click here. We need to select the temperature load in the load type, a thermal load. So again here we need to apply the member number start from 1 to 570. So the temperature load in Tx direction is -40, which we had seen in our calculation. So now the temperature load on structure also applied. We can also view this by clicking this load icon. So select display, right click and display, click load values. So you can see here -40 degree. Now we need to apply wind load on structure. There are 9 number of wind load we need to apply. That is in under extreme wind cases there are 3 direction, that is 0, 45 and 90 degrees. Similarly like for high wind and moderate wind also we are having 3 direction. So totally it is 3 into 3, 9 number of load cases we need to add it for wind on structure. For doing this wind we are going to go for wind simulation process. So we can close this and maximize this model window. So go to loads tab, click wind loads simulations, generate wind load. In that, so in the right hand side you can see the Excel sheet which is the 9 number of load cases which we are going to apply in this robot structural model. So here first one is we need to apply in y direction. So for that the magnitude is 2.57 kilonewton per meter square. So instead of wind velocity we need to apply it here the value 2.57, and openings in panels closed for wind flow. So this we can untick because this is a open panel. So here we can consider generated loads when loads deviation factor is less than 0.5. Now you can click start. Before that you need to check this element. We are going to apply wind load only on the structure, so 1 to 570 member numbers to be selected here. Click start. It will generate a simulation until the process get 0.5% in this value, in tabular value. Now you can see that extreme wind case for 0 direction is considered as load case number 21 by default. It had taken nearly 20 minutes to generate this load case. So similar like we need to do it for other cases, such as for next one is extreme wind case in 45 degree. We can select this x plus y plus direction. So the magnitude remain same 2.57. No, actually it should be 1.82 as per our calculation, and the number of elements are same. So if we want to take this time duration for simulation to less than 20 minutes which we had calculated earlier, you need to type here 1%. So we can type it here 1% instead of, and click start. Then it will generate until this 1% is going to attain for all this table value. So I think we have to wait for another 10 minutes for this simulation process. Now the simulation process for extreme wind case for 45 degree is completed. So that case number is 22. Now we are going to apply for x plus direction, that is a 90 degree. The value for the same is 2.57. So again these parameters are same. Click start. So you can see now that the extreme wind case 90 degree direction also created as a load case number 23. So likewise we need to do it for high wind and moderate wind for all the three directions. So finally we had calculated, we had applied all the three wind load cases, extreme high wind and moderate wind, even that sub cases like the directions also applied. The final one is 29 cases, that is for moderate wind for 90 degree directional force, it is 1.54. So that's all about the primary load application or applying method in robot structural analysis. We will see in next video about the load combination. Thank you. Look description for more related videos. Subscribe to this channel for more updates. Thank you.